Mr. Bergman, it's good to see you again.
Yeah, good to see you too.
So one of the things that we talk about often in class is how it's okay to fail. Failure is when you learn, right? I mean, you don't get to learn stuff just by getting the right answer. So to that end.
Yeah, hey, we did a video where we did a total fail. So let's watch our failure video.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and neodymium, and germanium, and iron. There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, plutonium, germanium, and iron, and.
So you can see we totally fail at. I don't think we'd be very good at TikTok. I just don't think you and I have the TikTok thing going.
And I don't think that the demographic of 50-year-old men is really what they're looking for either, right?
Yeah, I don't think I'd win that contest. But anyways, speaking of TikTok, or maybe not speaking of TikTok, periodic tables. The periodic table has like all the elements on it. And we want to do a brief introduction to like the periodic table and these protons, neutrons, and electrons that we've been talking about before.
Yeah, if you have a periodic table on hand, I'd say pull it out while you're looking through this video. Wouldn't you agree, Mr. Bergman?
In fact, actually do that. Get it out, and you're going to start marking up your periodic table.
So in chemistry, the periodic table of the elements is like the deal, right? You've probably seen this, like, oh my gosh. All right, so periodic table has some numbers. We got to know what the numbers mean. So copper, element number 29, and this number 63. The element number 29 is called the atomic number, and it represents, most importantly, the number of protons in the nucleus of the atom. So copper has 29 protons, platinum has 78, cobalt has 27. You get the idea? The second thing that the atomic number represents is it also represents the number of what?
Electrons.
The number of electrons if the atom is neutral.
Yeah.
That means it has no charge. Again, we'll learn later about what that is. And then lastly, there's this number on the bottom. This number on the bottom, we're going to call it the atomic mass. Right? Atomic mass, now you might notice it's 63.5, whatever. We usually just round to the nearest whole number, with a couple of exceptions. And this is the weight of the atom, and the weight of the atom is found in the nucleus of the atom, and it represents the protons and the neutrons, where a proton weighs 1 and a neutron weighs 1.
We'll get to that in a little bit. But the takeaway here is this. The number on the top, it is the most important thing because it defines the atom. So if you were to put your finger on lead with 82 protons, every single lead atom has 82 protons. If you don't have 82, you're not lead. In fact, let's say you're 81. You can't be like, yeah, I'm lead, because you're not part of that club. Now, back in the day, the alchemists used to say, hey, we can take useless metals and transform them, transmute them. And I used to laugh at that. But guess what? If you start off with 82 protons and somehow you were able to take 3 protons away, wouldn't you have gold?
Absolutely.
And the reality is we can do that now. Now, it's incredibly costly to do that, lest you think you're going to be taking a bunch of lead and making it into gold. But the reality is if you take something away from this video, know that the atomic number, these numbers right here, for example, hydrogen with 1, etc., that defines the atom. You do not get to mess with that ever. Now, you can change the number of electrons, and that impacts your charge, which is what we're going to be talking about a little bit later. Anything more to add here? Back to you.
So guys, I'm going to make a chart right now, and we're going to fill this in so you get a good example of how this looks. So let's start with the simplest element, hydrogen. So if we look at the periodic table on hydrogen, we can find the mass of hydrogen. And so what is the mass of hydrogen, Mr. Dimitrievich?
1.008.
So we're going to round to the nearest whole number, folks. So just round to the nearest number, so that's going to be 1. All right, and then of course the atomic number is equal to the number of protons, like we said. So how many protons do you have of hydrogen?
Just 1.
Right, and remember we said this
because of the number.
Yeah, because it's the number. Remember that the protons plus the neutrons is equal to the atomic mass. I'll call it the AM. And this is a little bit tricky because they have to add up. So 1 plus what equals 1. So how many neutrons do we have? We're trying to figure out. How many neutrons do we have?
In this case, you'd have to have 0.
Yeah, 0. So this is a little tricky one. It's the only atom that has no neutrons, as it turns out. And then the electrons are always equal to the atomic number. Well, not always. We'll talk about later about how the fact sometimes they can lose and gain electrons. But here's the idea: is that it's the number of protons, the number of electrons will be the same in the neutral atom. We're just doing neutral atoms. And so if we look at sulfur right here, with sulfur, I'm looking on the periodic table right here, sulfur has an atomic number of 16. So this is 16 and this is 16. And if I look at the number, it says here that sulfur is 32, rounded number, 32. So how many neutrons are there? If you think of these two numbers have to add up to these two numbers. So 32 minus 16 is 16. See, these two, if you will, have to add up to this one. Does that make sense? Equals that, right? Now let's do 207. So we're going to find somebody with an atomic mass of 207. And if you look and look and look, you're going to find just one substance that has atomic mass of 207. You're going to find that's the element Pb. And recall that's lead. And if you find Pb or 207, you're going to find that his number of protons is 82. His atomic number is 82. This will be 82 as well. And then the number of neutrons, remember this number plus this number has to add up to 207. So I'll take 207 minus 82. So that's 125. You put 125. I think you're kind of getting the pattern here. If you've got 79 protons, that tells you what the element is. So if I look on the periodic table and I find element number 79, I look here, and I find that that is the element Au, or gold. And if I find what is his mass, I'll find that here. That is going to be 200. If this is 79, that makes this 79 because they're both protons and electrons. And this will be 200 minus 79. So maybe you need your calculator, 200 minus 79. And that gives me 121. Hopefully you're starting to see the pattern. Now these two are interesting because you're just given the atomic mass and the number of protons. So this is 40 minus 19 gives you this number, right? So that's going to be 21. So on this one, we've got, by the way, I erased one of the numbers here, so we're just not going to do it. I think we've got enough information here. If this is 19 protons is the element potassium. And of course, this 19 is this 19 as well. So folks, you're going to be doing some of these types of problems in your worksheet. And hopefully you've got the pattern. The key thing here that people struggle with is protons plus neutrons is the atomic mass. And the element is always associated with the number of protons, which is also associated with the atomic number, the smaller number that you're going to find, with the exception of hydrogen. And the electrons are always the same as the atomic number when the atom is neutral. Mr. Dimitrievich, any other thoughts?
Nope. I think use the periodic table as your friend.
All right. We'll see you guys in class.